大家介绍一下。你好，大家好，我是陆东，我是从来自这个普林斯顿学习体验。那么今天我们非常高兴呢，今天欢迎同学和家长呢对我们这个教学这个项目非常感兴趣，非常感谢。今天我们很高兴的请到了这个国家空间协会的 Mark Barakat 教授来主持我们这个物理学和这个基础天文学的公开课。Mark Barakat 教授呢，有这个对初中和高中的学生的教育呢很有热情，他有这个多年的把大学的这个天文学和物理学的这个课程呢讲授给这个初中和高中同学，那这个帮助大家呢，带领大家探索这个宇宙空间和这个对科学探索。同时呢，他是这个国家那个空间协会的呢 NSS 的呢STEM 的项目呢，在这工作了很多年，帮助过很多 international student， 这个国际学生呢，这个获取呢各种各样的大赛的奖。那么每年我们知道这个国家这个Space Society National Space Society 国家空间协会都会给初中生和高中生举办那个 STEM 项目的大奖赛。这不光是这个national 啊，是国际这个学生也在里面。那这个他有Mark Barakat 教授呢有很多年的这个经验，他非常愿意呢也帮助我们的同学，在美国的同学，不光是 international student， 帮助在美国同学呢能够提高这个科学的水平，拿到大奖，也是呢对这个同时呢也对你帮助你呢在这个今后的大学的升学的过程中呢能 stand out， 能够非常突出，那么比这个其他竞争选手呢有更大的竞争实力。这是这个Professor 这个 Mark Barakat 非常愿意跟我们一起这个做的事情。Hello, everybody, every student and parents. Welcome to our open house at Princeton Learning Experience International School. Today, we are very happy to invite the Professor Mark Barakat from National Space Society, and he has many years experience and passion to help to bring the college level physics and astronomy courses to middle school and high school students. And he also worked in the NSS NASA as a STEM program for many years to help a lot of international students get different kind of award in the, and he really want to share the experience, knowledge, and know how to help our students not only lead you inspire the science and space, but also help you to do well in the test the competition and in the NASA and NSS, and make you stand out and get better opportunities for your higher education. And let's welcome Professor Mark Barakat.
Thank you, Sadon. Good evening, parents and students. Welcome to this open house towards, let's call it a career path in science. My name is Professor Mark Barakat. I will be your instructor in not only teaching your students, but in being able to offer them many benefits not found in conventional school science programs where you use textbooks. I received, I'm going to start my presentation. Bear with me 1 second. Okay. So as I said, this is called Welcome to a New Way of Teaching. I received my Bachelor of Science in Physics from CUNY, and then later a master's degree in astrophysics from California. I did some work, I did a lot of work at observatories in the US, researching the elements found in stars. I am privileged to also work for the National Space Society, Washington, D.C. Now, after years of being in observatories. I became a lecturer on the subject and a certified space ambassador and National Space, that's National Space Society. So I became a certified space educator when I joined National Space after years of doing astrophysics. And my position was to visit various middle schools, high schools throughout the northeastern seaboard and lecture them in either full courses or assemblages of students on the subjects of astrophysics, astrobiology, cosmology. So many of the courses available to you throughout schools throughout the region. So you may be asking, why should I register? Why should my children register for your classes? You may be asking, what makes your classes so different than others? And how will they benefit from registering for these classes? And these are all great questions that I will attempt to answer them in this open house. First of all, I use the latest information available to me from associates I have at the Planetary Society of America, NASA with their STEM, Science Technology program, and National Space Society. In addition to National Space Society, we also employ some teaching methods from the National Science Foundation. Now, my lessons are constantly being revised all the time. What I taught to students 3 years ago has changed now because physics, general physics, especially the world of astrophysics and space tech, is continually reinventing itself. So when new discoveries come along, they rewrite what we taught last year. That is why it's critical that you have the most up-to-date information. By reading science from your conventional textbook given to you in school, you don't have the latest up-to-date knowledge. As a member of the National Space Society, my course is in agreement with this organization here, the National Center for Science Education. Now, the National Science Educational Standards represent a consensus of thousands of scientists and educators regarding specific courses of area of study in the fields of science where you are most likely to be employed. Right now, the major fields open to people in science for employment are aerospace, astrophysics, biotechnology, and space technology. Companies directly involved in these fields are seeking future movers of tomorrow. The future Elon Musks and career successful people will come from these industries. So you can be sure the lessons that I give in different areas of science are cutting edge and viable, not dead-end science. Areas of study industry recruiters need from their candidates. Because of this, I do not teach history lessons on Galileo, Newton, or other famous inventors like most courses. I teach practical application of their laws. I do not teach urban legends you find in these antiquated textbooks. Urban legends like the apple falling on Newton's head or Franklin's kite experiment. I also teach, in accordance with this National Center for Science Education, university-level science, but brought down to a level of understanding without the complex calculus, equations that they're frustrating. I have, and I believe this was a year and a half ago, I taught particle physics to elementary school levels. They were able to understand and they enjoyed it because this is something that they don't get exposed to in the normal middle school curriculum. So as I've stated, I use STEM-based lessons in online programs. PowerPoint lessons and films available to me. One of them we'll see today from NASA Goddard Space Science Center and the Jet Propulsion Laboratory out in California. I use these to drive home the point and make the lessons fun, because if it's not fun, it's not desirable. For example, when I teach about the moon, I'll be teaching you about the moon, but we'll also be using Goddard's film of the Lunar Reconnaissance Orbiter flying over the surface from less than 6 miles. And we'll be picking out important craters, important geophysical things. Now, as you can see from your screen, a lot of my stuff comes from NASA, NASA STEM. So we're always teaching cutting edge science to you. Now I've saved the best for last. Before getting into course specifics, as a certified space ambassador with NSS, I have entered my past students wherever I taught in a space settlement design contest. This is a national and international competition. This is held at the ISDC, which is the International Space Development Council and Conference, and this is an annual event. Now, a lot of people don't know this, but this is for grades 6 through 12 and high school level. The contest is for students. It is sponsored by NASA Ames Research in partnership with National Space. Many years ago, there was a Space Act agreement between National Space Society and NASA, where we have a symbiotic relationship on this subject. Entry groups for projects get picked up to appear at the ISDC, and winners, besides medals, can win scholarship money. Here is a group of middle school children that won this last year's space settlement design competition. And as you see, it's just a lot of fun. You have group t-shirts, you get to name your own project. But more importantly, if you get picked to go here, you get to meet and greet people from the aerospace industry, from NASA. You get to meet scientists, engineers, nuclear physicists, bioengineers, people from Boeing, people from Goddard, people from SpaceX. Companies directly involved in the exploration of space, the development of rocketry and spaceships to take us into space. Hopefully, we will be able to do this here. We're working on this possibility. This is extremely important, and I can't emphasize enough the importance of extracurricular activities to your career. Joining planetary societies, national space. Employers want to know that your interest is so important to you, and they judge this not only by your academic levels in school, but by extracurricular activities. It is vital. So let's look at our courses, and we'll get into first the middle school program, the university level science. And here again, this is one of the middle school, I believe, no, this girl is a junior. And she did a project called ARIS, A-R-I-S-S, and she is lecturing to the group of scientists that are the judges at this competition. Here you see, I love this because it's just a great slide. We have NASA Ames Research, which partnered with us. Here are groups of students you can see with their projects. This, yes, that's Transformers. They did a robotics project. And these are all the winners of last year that are on stage, receiving their medals, their awards. So it's just a great addendum to this program. National Space Society also features a day in space where we celebrate all things space. Not last year, but the previous year, we held this in New York City, and hundreds of students came from the various schools in the tri-state area to attend this. We feature astronauts and industry leaders talking to you on different subjects about your career. So let's take a look at the first course, which we're going to talk about on middle school. Before I do that, I just want to impress upon you, in 2018, the Science Recruitment Group said the best paying and successful jobs come from engineering, biotech, physicists. The widest range of positions are environmental physicists, satellite tracking physicists, astrophysicists, and of course the field of astrobiology, which encompasses microbiology and space nursing. So you have a wide range of career opportunities. As I've said, people look at your extracurricular activities. It's very important, okay? This course not only will teach you specific areas of science that you don't get exposed to in regular school, but if hopefully we can partner and do this with our students to join this national contest, it takes it to a whole other level, because you're not only reading about what you want to do, you're meeting with actual people that work in the field of science, and you can talk to them, you can meet, you can greet them. They'll give you advice on what courses to take, how to go about doing this. So let's begin. University level science taught at middle school. Now remember, these are specific, this whole course is specific for what we want to achieve in science. We're going to be teaching you, in part one, we're going to teach you about general physics. We're going to introduce you to the worlds of sight and sound. You're going to learn all about the electromagnetic spectrum. You're going to learn how light waves are particles and waves. This lesson is most important because it will teach you principles about radar technology, sonar technology, astrophysics. We're going to study the science of rainbows and the visible spectrum. In 6 lessons, we're going to study the laws of physics, thermodynamics, motion, acceleration, electromagnetism. We're going to teach you how rockets work. We're going to study escape velocity. You're going to learn the formula for escape velocity completely, I promise you. As you can see, this is our high school level senior escape velocity class. This is our middle school, and believe me, you will learn this only in this style. We're going to teach you in part 3 about, we're going to introduce you to the world of chemistry and biology, but not how you get it in your regular school setting. We're going to teach you the physical part of chemistry. We're going to teach you chemical engineering. We're going to teach you biology, but not what is a cell, what is a protein. We're going to teach you biology with DNA sequencing, genetics, things that industries are looking for now. In part 4, we're going to teach geophysical science, earth science. We're going to teach you about, and again, they don't get into this in this level of detail in school. We're going to teach you about geology. We're going to teach you about earthquake science, volcanoes, tsunamis, environmental science, like paleontology, atmospheric science. Why do we teach you about earthquakes? Why do we teach you about seismology and volcanology? Well, let me share something with you. When we go to the moon in 2024, we are looking to start a program where we will form habitats inside lava tubes from ancient volcanoes. This is a goal of NASA. They're going to need geologists. They're going to need volcanologists because we tend to hollow out lava tubes and build actual habitats. Why? Because it'll protect people from the harsh environment of temperature and from the ultraviolet radiation from the sun. This is a definite, real project that they are planning, and they've been planning for the past 5 years. I gave a lecture on this last year at the ISDC. So let's look at, as we continue in part 5 of our course in university level physics, we will go into astronomy in 13 lessons. You'll learn about the sun, you'll learn about atmospheric conditions on different planets. You'll learn how the moon was created. I don't know if you're aware of this, but our moon was the result of a collision between Earth and a Mars-like planet. When they collided, it left Earth looking like the Death Star from Star Wars, and slowly Earth regenerated itself, but all the pieces from the collision between Earth and that planet form the moon. So these are things that you just don't get in a regular classroom atmosphere because we have the time here. We're going to teach you about black holes. We're even going to teach you about how to process alien language, believe it or not. That is an amazing class that NASA has set up. So let's go into the basic astronomy for high school. These, again, are university level courses, but we don't really bring them down to middle school level now. This is, we're talking an incredible amount of basic astronomy in 40 lessons. And I'll explain to you how it differs. We start off on the surface of the Earth with atmospheric science. Now, why would we do atmospheric science in an astronomy program? Well, a lot of our students from this course work in meteorology, they work in aerospace. You'll get to learn in this part of the course the science of flight, the science of falling. We're going to take you through anomalies in the sky, lunar rainbows, tsunamis on the sun, moonquakes, sunquakes. We're going to study, after we get through a very detailed look at this, we're going to study celestial mechanics, terrestrial mechanics, universal gravitation. We're going to teach you the reason for the seasons. We're going to study about the telescope, Earth-based, space-based, and the backyard telescope. I love these lessons on the telescope because we're going to have a telescope here. We're going to show you a program, and we're going to go into the program on how to set it up so that when you point it at the sky, the imaging will appear on your computer, and we're going to use programs that were designed by scientists in the field, and you'll learn about celestial coordinates, the coordinates of stars, the right ascension and the declination, to capture the image through the telescope, put it on your computer, and print it out. We're going to study principles of astronomy in many lessons. Then in part 2, we're going to take a look at the night sky. We're going to look at constellations throughout the world. We're going to study solar dynamics about the sun and get into nuclear physics. We're going to study about all the planets. We're going to go through comets, meteors, asteroids, quasars, pulsars, magnetars. We're going to study about the Milky Way. We're going to study about black holes. And at the end of it, as a matter of fact, here's one of the classes. This is on how to classify stars with the Hertzsprung-Russell diagram. This is stuff that you don't get exposed to in your basic astronomy class. But this chart is so important. It is the Earth, it is the basis for what we do in astrophysics, how we classify stars on the basis of their temperature, their elemental composition, through spectral analysis. We're going to study mechanics. And finally, in our last lecture, we're going to talk about something that happened in 1956 with 4 Nobel Prize winning scientists that revolutionized the course of astrophysics. We're going to teach you, and maybe you're not aware of this, but that all of the elements that are in your bodies, your aluminum, your iron content of your hemoglobin, all the elements, calcium, silicon, phosphorus, magnesium, that are in your body, got there as the result of exploded stars. There are supernovae that exploded millions of years ago, dumping their ejecta over the surface of the Earth. So essentially, we are made of stardust. Again, I know they don't teach this at school, but this has been known for the past 90 years. Astrophysics is based on this. So I hope you'll agree this program is different. It will prepare you and your children for a career in science, teaching them the specific areas of science they don't get exposed to in an open classroom. In addition to this, as I said, we hope to include the National Space Society's program of the Space Settlement Contest. These classes, if I can say this, are a springboard for what we intend to offer in the future in different areas of science. Not only that, but if you do this, you will be on a level that you just cannot imagine insofar as being ahead of the grade compared to everybody else. I'd like to just close. People are asking, are we in danger from asteroids? No. Isn't that planet called Theia? Yes. It's called Theia, that's correct. Are we in danger from asteroid Apophis? No, we're not. No, we are not in danger. There is a program that NASA has in development where you don't need to blast asteroids out of space. All you need to do is send up a device that will deflect the asteroid by as little as 1 millimeter. It will change the trajectory. So we're not worried about anything like that. Brendan, I see, said he learned that on his library. Martin, I see we have quite a number of students here. Is Earth threatened by Gliese 710? No, not at this time. I see we have a number of students here. It's very interesting that a lot of the students have questions about NEOs or asteroids, comets, and meteors hitting the Earth. It's very interesting. When we talk about asteroids, we will explain to you about the deep impact programs NASA has developed to deflect these. Also, what they do is there are computer simulations that NASA uses based on the material the asteroid is made out of, the trajectory as to an impact zone, and the results of a direct impact. That technology NASA is extremely interested in and they're working on now. That is why in the latter part of the program we talk so much about comets, meteors, and asteroids. It's a big part of what NASA is doing now in the research. As I said, National Space Society partnered with NASA and Ames Research. So we get a lot of information from NASA on all of these near-Earth objects. We call them NEOs. One person said to me, have you ever talked to astronauts on the ISS? That's very interesting. I have not. I have met a number of astronauts at the NSS meetings. A couple of schools in Phoenix, Denver, Oregon, Tennessee, were able to speak to astronauts through NASA's STEM program while they were on the ISS. Classes were assembled and they directly asked questions to a lot of the astronauts. That's a very good question. When will Halley's Comet fly by Earth? Halley's Comet has a trajectory of every 75 years. Interesting to note, I'll tell you something about Halley's Comet. This is from Lee O'Connor. Originally, when Halley's Comet hit, the world, it was sort of like the pandemic is now. The whole world thought they were going to cease existing because all of the newspapers, all of the periodicals at the time in the early 1900s threatened that we would all be wiped out. Why? Because Halley's Comet, when scientists studied the trail of the comet, they found the element cyanogen in it. Now, cyanogen is a derivative of cyanide, which one drop can kill you. So you can imagine how everyone on Earth started thinking they were going to die by inhaling the cyanogen. And there were charlatans at the time that made comet helmets, comet masks, comet umbrellas, which I don't understand, but anyway, all these charlatans tried to make money off of this, even in the midst of all this doom and gloom. But it turned out that the comet trail is extremely, we talk about this in physics, it's extremely rarefied, which means it is of so low density that the amount of cyanogen in the comet trail is negligible. And it's just so thin it wouldn't affect you. That's a very good question. When will Halley's Comet fly by? Is physics a prerequisite? Yes, it is. Jaden says, is physics a prerequisite? Absolutely. Any area you go to in science, they want you to know physics. You have to know physics for chemical engineering, definitely aerospace, astrophysics, absolutely. So physics is a big deal. Also in physics, it is it's better if you concentrate on the field of thermodynamics. If you're going into engineering. So yes, physics is a definite requisite. It absolutely is. Let's see what other question. Oh, we have so many questions. My goodness. If Molin Wang says, I like the planet where we live. Christopher says Uranus. Brendan says, I love Jupiter. Without it, Earth wouldn't exist. And Brendan, son, you are absolutely correct. Without Jupiter, we wouldn't exist. From Alex, if I'm in 8th grade, should I sign up for the middle school class or the high school class? Alex, I would say sign up for the middle school class, because we'll introduce you to geophysics, environmental physics, and you would like to get into. Let's see what else. I think that's pretty much all of our questions. But all I can tell you is you'll learn things here that you don't learn in your conventional classroom setting. And we have a lot more resources. I didn't mention this, but when I teach earth science and when I teach astrophysics and all. I have a number of artifacts I can have to me on loan, given to me by various museums throughout the country. So when we study earth science, I'll show you geological samples of rock from when all the continents were one, from Pangaea. I have these. I'll show you amino acids that were captured from the regolith of the moon and brought back. We'll show you these. We'll show you when we get into extinctions in earth science. I have a core sample of every section of the Earth's crust, and in the middle, you'll see when the asteroid struck. This is a core sample from Oregon. So we have a lot of things to show you, physical things too. We'll show you we'll show you meteorites. We'll show you pieces of asteroids. When we get into dinosaur extinctions, we'll show you teeth from various dinosaurs that we have. When we get into our study of lightning, I actually have petrified lightning in a bottle. We'll show you that. So there are a lot of things you will see here that you don't get the opportunity to view in class. I have two other questions. I have from Brendan. Is this class high school or middle school? The middle school class is general physics. The high school class is astronomy. And let me say this, that course I'm teaching you in astronomy in high school, I have taught in high schools. I also teach advanced astronomy. That basic astronomy course is the basis for the advanced. I also teach full courses in astrophysics, a little bit about astrobiology. I'm not that knowledgeable on astrobiology, but I do teach it from the point of view of microbiology. But I also teach cosmology. Cosmology is the study of the universe, and I have an 18-lesson course on cosmology. Now, my courses on cosmology, astronomy, basic astronomy, these are all university-level courses. So those high school courses, you're going to be learning what we teach in university. So it's cutting edge and it's not stripped down. But if you're interested in astrophysics, I would definitely urge you, if you're in middle school, take middle school course, because I have a number of space-based lessons in the last part of the course, and you'll be amazed at what you learn there. Leo Tana says, have you ever used the Hubble telescope? No, I've never used the Hubble telescope. I did meet one of the designers of it at one of the ISDCs I attended. But interesting. I have one interesting thing to add to that question. NASA is going to launch the James Webb telescope pretty soon. And the James Webb is going to be, compared to the Hubble, it's going to be like 8K resolution compared to 720 on your TV. It's going to be incredible. I believe the mirror for that is over 4 meters. So it's an incredible, incredible telescope that's going up soon. And I think that answers all of our questions, sir. No, we don't have a lot of homework. No, I don't believe in giving a lot of homework. I do give tests based on when we finish one of the parts, I give a test. The test is usually multiple choice. As far as homework goes, I do have homework issued at the end of every lesson, but believe me, it's only 1 or 2 questions, and a lot of the time, it's one of the questions is speculative, the other one is actual. I want an actual answer, but it's no, not at all. I don't believe in a lot of homework. I believe in a lot of extracurricular activities. Homework maybe not one of them, but we do give homework. The homework is not heavy, not. Christopher, to everyone, is this class every week? Yes, I believe tell you that my lessons are very detailed. So I have a lot of information for you that I can't do in 10 lessons. Impossible. Let's see. A lot of homework just like in school? No, Molin, there is not a lot of homework. We're talking 1 or 2 questions at the end of every session. That's it. Is there any book you can recommend me, says Brendan's son. Yes, there are books on astrophysics published by Cambridge Press. There is an absolutely incredible book, and I would urge everybody to try to find it. It's called The Cosmos by a gentleman, by a scientist named J-A-Y Pascal, P-A-S-C-H-A-L. And that is an extremely detailed and college-oriented book on the subject. There are multiple calculations and formulas, and yeah, it's extensive. It's about 800 pages. I would not recommend it if you don't want to do a lot of homework. Leo kind of says, is Proxima Centauri B a habitable planet for humans? That's very interesting. We go into this in advanced astronomy. We talk about the Doppler effect. NASA has programs now where they're studying where life would be in space. We look at habitable planets. In other words, basically it is this. You have the sun and you have planets around the sun. Those closest to the sun would not be habitable. Those furthest away would not be habitable because it'd be too cold. So we are looking for planets in what's called the Goldilocks zone, not too hot, not too cold to support life. Very interesting question, Lee. In the solar system right now, we have a number of discoveries that we didn't know 2 or 3 years ago. We know that, and I'm going to teach us in the course that on Mercury, which is the closest to the sun, there is snow. There is snow at the North Pole and the South Pole on Mercury, which is only 67 million miles from the sun at perihelion. So we're also looking on Mars for signs of life. Now we found water on Mars. NASA is planning a trip to the moons Enceladus and Titan. Those places we expect life because on places like Titan and Enceladus, there are oceans of teeming with water. One of them, the ocean is encased under the mantle. And we believe there are thermal vents. When the Cassini spacecraft passed through these bodies, we saw geysers coming off of the surface. So where there's thermal vents, there is microscopic life, just like on Earth. And we're going to look at these places for life. That's where we're going. Molin asks, there's an exoplanet that rains diamonds. That's Brendan. Yes, there is also a lake of diamonds inside Neptune. We're going to teach you when we talk about meteorology and different planets. You're going to learn things like clouds on Venus rain battery acid, the same battery acid that's in your car. There are places in space that rain liquid iron. There are a lot of different meteorological anomalies in different planets. Jupiter has 28 alternating airstreams. We get into a lot of this. We get into the Venusian vortices. We'll talk about the Martian sandstorms. Well, even when we do our lesson on Mars, we'll show you about the Marinus caverns. We'll show you about Olympus Mons, which is the biggest volcano in the universe at an incredible height of 15 miles. So, and I actually have, from NASA, I have 3D cement modelings of these places. So we'll get into detail when we show you those. But there's so many things that you have to learn, that you will love to learn. Mullen says, is there a book made of paper that we can buy in the bookshop? Yes, Mullen, you can buy that book that J. Pascal wrote, but it's extremely detail oriented. It's really hard. It's definitely upper college level. If you want to study things at a little smaller, like a little lower pace, there are books from Drake Publishers on the subject. There are a lot of astronomy books. If you go to your local bookstore like Barnes and Noble and you go to the science section, there are a lot of books, specific books on astrophysics. Let's see. And let's see. Okay. Oh, good. I live near a bookstore and a cartoon show they climbed it in 2 minutes, but in reality, it would say, yes, that's true. That's true. I can see all of your questions are really, really interesting. And there are no crazy questions. With space, everything is on the board, is on the table. As a matter of fact, I'll tell you something very good. I think I wrote it down. Bear with me 1 second. Hold on. Yeah. If you want to study this, there is an excellent thing. It's actually a series of photographic cards called a photographic synopsis of the universe. And you find them in Barnes and Nobles. I'm sure you can find them on places like Amazon, but these are a series of maybe 300 cards. Each card has a beautiful rendition of subject from NASA, and on the back, a lot of information. That is incredible. I think it retails for like $30 or something, but I would definitely look that out. A photographic journey through outer space in the solar system. It's encased in a box, and there are about 300 cards. That I would recommend you get. It's really, really good.
I'm sorry, Professor, and we run out of time.
Okay, and, yes, I understand, of course. Thank you.
Yeah,
thank you so
for everybody.
Much, sir.
And we know a lot of students still have a lot of questions. We welcome you to join us this coming Sunday or next Monday. That's Sunday is for high school class, and Monday is next Monday is for the middle school class. We welcome you all join us. You can keep any question you can ask Professor, and he would like to help you and lead you explore the science space, and also help you on the competition in the NSS and NASA. Thank you. Thank you for everybody.
Thank you. Thank you, sir. Take care, students. Take care, everybody. We'll see you soon. Take care and thank you. Thank you, everyone.